Let's take a look at this next one. We've got x minus 2y equals 4. Again, it's in standard form. So even if they didn't ask me to do it this way, I'd probably be inclined to do it this way, which is to find the x and y intercepts. Okay, well, that means we're going to make a table of values where we're plugging in 0 for x and 0 for y. So we've got x minus 2y equals 4. So we're going to plug in 0 for, let's see, for x first. Well, let's plug in 0 for x. What happens is that whole piece falls apart and just vanishes, and we end up with the 2y still equals 4. So the last thing that we would do is divide both sides by a -2, which will give me that y equals -2. So that means when I plugged in an x of 0, I got out a y value of -2. So that means I'm going to go down to -2 on the y-axis, but I won't go left or right. And that gives me a y-intercept here of this point 0, -2. Again, it's a y-intercept because I'm intersecting the y-axis. I only have a y value as well. Last one here. They want us to plug in 0 for y, so I've got to rewrite my equation somewhere, which is x minus 2y equals 4. And this time we're plugging in a 0 here for y, which means I'll have 2 times 0 here, which means that will just vanish. Oh, well, that's nice. Then I just only have an x equals 4 then. How nice was that? So we got a 4 for x. So we can graph this point as our x-intercept, which means I'm going to go to the right 4, because my x value is 4, but my y value is 0, so I don't go up or down. So my y-intercept is just the point 4, 0. 4, 0. So now I have my 2 points. They're graphed. All I have to do is play connect the dots here and go past my actual points, draw my line, make sure I do arrows, and let's see, draw my arrows at the end, and I am all done. So I will warn you about my math lab. If you're using my math lab and they ask you to graph a line using the x-intercept and y-intercept, if you do not graph the line using an x and y intercept and you use different points, even though your line is technically correct, they will mark you wrong. Why? Because you didn't do it the way that they asked you to do it. However, on a test, I will do the same thing. If I'm asking for an x and a y intercept, I'm going to ask for the x and y intercept, and I'll actually make you find those points. But when you actually go to graph it, you can graph it however you want. This just does happen to be the easiest if it's in standard form. Let's take a look at this next one. Next one, we've got the equation y equals -2. This one's a little different. And it's a subtle difference is that we don't have an x. We only have y's. So something special is happening here. Question is what? So if we were to do a table of values, what this is saying is that no matter what, my y values will always be -2. So that means all my points, no matter what they are, will have a y value of -2. My x values could be anything. They could be 0, 1, 2, but my y values will always be -2. Well, these are just example points. Let's plot them and see what makes them so special. So if we plot 0, -2, we'd be going down to -2. The next one is 1, -2, which means over 1 and down to -2. Next one is 2, -2, so over 2 and down 2. What are we noticing about our points? Well, notice they do create a line, but it's a special line. So let's play connect the dots and draw our line because we needed only 2 points, but we've actually kind of gone overboard and done 3 points, is that we have a horizontal line. So that's what's happening that's special if we have just a y in our equation. So horizontal lines are always going to look like this. They'll have y equals just some number. So let's see. And because they just have a y value, notice the only axis that they actually hit is here. At -2, you only hit the y-axis. Notice you never even get anywhere close to the x-axis. You just stay horizontal. But if you want to graph a line that's horizontal even, in my math lab, you still need to use the 2 points. Just do them side by side, and then my math lab will draw the horizontal line for you. Now let's take a look at the next one. Notice in the next one we only have an x. So I bet you can guess what's going to happen in this one instead. We have, let's see, x equals 3. So what's going to happen when we just have an x instead of just having a y is it's going to be the same idea as we can do a table of values, just like we did for the one above this. And this time it's going to be all of your x's that are staying the same. So no matter what, your x's are going to be 3's all the way down forever. Your y's may be 0, 1, 2, other numbers, but x is always going to have to be 3. So let's see what happens if we plot, let's see, the first couple points here. Well, 3, 0 is over to the right 3, but doesn't go up and down. And so the next one, 3, 1 goes over to the right 3 and then goes, let's see, up 1. The next one, 3, 2 goes over to the right 3 and up 2. Notice we're still creating a line. We can still play connect the dots here and draw our arrows at the end like before. This is still a special line, but this is a vertical line now. When we just have x's, we'll end up with a vertical line. So this will be x equals some number whenever you have a vertical line. And notice, when you just have an x, you only hit the x-axis. You hit it at whatever number you had, which was, in this case, 3. Just like in the last one, we only hit the y-axis here at -2 because that's what was in our equation. We had a -2. So there's really only 2 special cases. Either when you only have y's or you only have x's, and those get you your 2 special kinds of lines, horizontal and vertical. Let's take a look at a couple more. In this next